Once you do a little strip of aluminum and you light it, it gives you a bright light. Yeah. So that is aluminum. Aluminum is light, it's strong, but it's brittle. So you can have aluminum skins, you can have aluminum hubs. There are certain, they can use, magnesium. I'm sorry. Magnesium can only be used in certain places. They use it for undercarriage upper trunnions, they are called, where the undercarriage is attached. They use it on wheels and they use it on control surfaces also because it's much lighter. But it is very corrosive and it's got a special treatment and a special coating on it. So if there is any damage on it, there is a special acid that you are supposed to use and then protect it and then put the paint scheme on it. So the aluminum, and of course corrosion is identified by visual also, like on rust is brown in color and flakes. Aluminum is white dust, whitish dust. Yeah. On copper you will see it changes color to green. Yes. Yeah. So that is corrosion. On copper is green. So you must know. There is nothing else, I think, more or less. But those are the three main I can point out to you. And there are treatments. There are different types of treatments that you can put on steel parts. You can cadmium plate it. You can anodize the aluminum. What else? Passivation. Then using pure as an oxide as a deterrent. So the outer layer becomes oxidized very quickly. So it slows down the process. It does not prevent corrosion. That's what I'm trying to tell you. Be very careful there. Yeah, you can never prevent corrosion. Yeah, so if your corrosion protected is done properly, it will last the speed of your aircraft. This is a fuel bed. Yeah, fuel tank. The fuel tank is from here to here. Okay, on the top. It's inside. It's a rigid tank. So it has to be vented. For fuel to flow, it must be vented, remember. Yeah. If it's not vented, then you can have full fuel starvation. And you have to always make it sure it's clear. That's why we put this little net on it somewhere, because what happens is doodles make their nest in here. And it is parked outside.
So how many tank beds is it?
Two. One here and one here.
How many liters can it roughly?
30 US gallons. 60 US gallons. So 60 times 3.8, about 240 liters. Will give you about 4.5, 5 hours of endurance. The average fuel consumption is about, you can go up to 8 gallons per hour.
These big aircraft have the engine near the tank. Is it not dangerous?
No.
Why?
It's designed that way.
Then, like, which one?
But the engine is not running when they're refueling.
So that's the reason why the nozzles is supporting the.
Yeah, but they have their special connectors, so it just goes from inside and then it pressurizes the fuel into the whole system. Here the tank is, you have to fill from the tank on the top. The guy comes with the bowser, he comes and fills up the tank. The filler neck is on the top. Okay. It's lunchtime now. Can you hang around for a while?
Yeah, we can hang around.
When is your class in the afternoon?
Our class starts at 2, so they have to be there by, they have to leave here by 1.
I'm talking about him.
Oh, no. That's
Can
what
we
I'm
hang
meeting.
around? Well, he's saying it's lunch time, so can we hang around for you to have this
Can
lunch?
you come back at 2? Dr. Yola?
No. Who?
Asked to talk to you, me and the teacher.
Yeah, because we want
yeah,
to
you
prepare
can
this lunch.
Yeah, come at 2. Then I'll show you the thing. Well, I have to finish this aircraft. In the morning you disturb me.
Yeah.
I have to finish it. These guys want this aircraft.
Okay. What we wanted to discuss, even including helping you guys with the work, you know.
Yeah, but the engine is a different subject, no?
Yeah.
And a piston.
Use washer
instead of
Yeah, there are lock washers also. There are different types of lock washers. There are star washers. There are split pins, split washers. The washer is split. Now, when you come to hardware, hardware is a major item. Andika, you. Huh? It's a completely new subject. Identification of hardware. What is the treatment on hardware? What treatment is used to protect? How it is made? How they are made? Rolled. You can have rolled threads which are stronger. You have cut threads by which are a little weaker. So all that is the hardware. Hardware is a subject on its own. Identification is very important. You should be able to identify a bolt by looking at it because it's got marks on it. It'll tell you whether this is a high tensile bolt, this is a close tolerance bolt. Close tolerance bolts means there is the ordinary bolt has a tolerance of plus or minus 1 thou maybe, okay, but a close tolerance bolt will have a tolerance of half a thou, or maybe in some cases exact size of the hole that you're putting it in, or just a little bit less than that, so that it can move into the hole that you want to put it in. So these are all, and then bolts also have different shear strengths. Yeah, ordinary bolts have certain shear strength. Then you have high shear bolts. So all this it's a special subject. So rivets will come into that. Split pins. Hardware is a big subject. Locking wire, different types of locking wires. What material, what tools you use. I showed you on the tools. We have the locking. We can lock bolts by putting a locking wire across also. Yeah. And they also specify what size of locking wire you should use. It goes from 21 thou to 40 thou on commonly that we use on common aircraft. Can have a bigger one on bigger aircrafts, might be thicker. Yeah.
so the spring pin and the wireless still are they using the same function?
Sorry?
The spring pin and the wireless still. The wireless
Wire.
the wireless still. Are they using the same function? Wire locking.
Yeah, wire locking is the same function because, yeah, wire locking you do where you have a blind bolt, which there is no nut on the other side. So it goes into a fitting. So you have put the bolt in place, okay? You have torqued it, and then you have to wire lock it because it can still come out loose. If it does come out loose, you have locked it with another bolt. So if the other one goes loose, it tightens this one. If this one goes loose, it tightens the other one. So it remains in place. It does not lose. It doesn't come out.
So then I want to ask, are they using the same function or they having different
The split pin is where you have a castle nut. Basically, it's accessible. You have accessibility on both sides. Is that the question you are asking me? Where you use locking wire, there is no accessibility. Say a bolt. Okay, say you had no access to the other side. Okay, I'm just giving you this is a hinge here, yes, and you had bolt one here, another bolt here, but you had no accessibility on the other side. Okay, so you attach the bolt on the threads here. Okay, and if this was vibrating, the bolt would eventually fall out, isn't it? So what you do is you lock this bolt with this bolt, so it will never work itself loose. That's when you use locking wire. Okay, the split pin. If this, you can open the door and there's a nut on the side with a castle nut, and you can put a split pin on it, then you can do that. You see, so it's a question of accessibility. Yeah, and a lot of the bolts and nuts on the engine, there is no accessibility because on the cylinder, you're not cylinder, but any attachment, say a vacuum pump, you're attaching it in place. So there is no place for locking it. So we use washers underneath the head, which are split. So if you look at a washer, ordinary washer is completely flat. There is a cut on it and it's split. So it's got a springiness. So when you casa the nut, it sits on that springiness sits, and there is a tension on it. So it keeps the nut from getting loose. That I'll show you when you come to hardware. I'll show you all the different samples of it.
I have this sample here. I wanted to understand the
Yeah, see, here is a patch repair that was done. Can you see this? Where did you get this? Okay. So see, this is a filler patch. Yeah. So this had a hole in it. Okay, it got damaged. So what we did is we took it out. We cut out the section of the damage. Yeah. All right. And then what we done is this we cut this. So this is very precise. You have to mark it, then file it. So you have to do trial and error. Usually what you do is when you're doing with trial and error, you mark a position. Then you put the filler patch in exactly the same position to line up. Because you can take this, you can turn anywhere around. You understand? And then when you push it into place, you will see where it is touching. And then you might need to file it a little bit to make sure it sits very nicely without any gap. An ideal one, this is good practice, is that when you have very little gap here, and then this is the filler patch that goes on the inside. Okay, so now then we riveted it, you see, and then we put 3-4 rivets on the filler patch, and this is a repair now that was done. Okay, just a good sample. I'll keep it here. Okay, so any questions?
Yes. Apart from aluminum, alloy material, is there any other material that is used in aircraft?
On aircraft, yeah, you use magnesium alloy. Magnesium alloy is much lighter, but it's flammable. Magnesium is flammable, yes. Okay, corrosion on a painted aircraft, you will see it like little worms occurring, under the paint. You will see like a worm-like shape occurring, and then if you scratch it, the paint will fall apart and you will find aluminum white powder at the bottom. That means it's beginning to corrode. So you have to clean that area, protect it, and repaint it.
So like there are some places of high temperatures. Which material is used?
Sorry?
There are some parts of high temperatures. Which material is used in those?
Yeah, yes. You can use on engine ducts, exit ducts. They use stainless steel. Yeah, but it's a special alloy. It's not like the stainless steel you find in commercial use. Yeah, it's a special light. They add the chromium and the alloy is there are different minor alloys they add together, which gives it the lightness and like exhaust system. They're made of Inconel. Inconel is again steel with chromium in it, certain percentage. Different percentages produce different types of material. So exhaust also. You can get stainless steel screws also, because the screws, again, when you put screw on a panel and you're going through the air, you will find the water will retain itself around the screw unless you paint the screw over. Yeah, but if the screw is exposed, it does catch corrosion. The screws are usually made of steel and you have aluminum skin, so there is a differential in material with different specific gravity. So if there is a different specific gravity, there is more chances of corrosion occurring in dissimilar metals. Similar metals, there is less likelihood, but dissimilar, it starts and it then accelerates very quickly because of the electro current that is passing through the airframe. Anything else?
Or is titanium used?
Sorry?
Which part is titanium used? Titanium materials.
Titanium. Titanium is a special material now, which is, it's very light, very strong, and very expensive. So titanium is used on leading edges, for example. Yeah. Titanium, now they are producing the undercarriage legs are made of spring steel. Yeah, they're making them of titanium now. It's very strong and lighter. So the lighter it is, that means it can carry more weight in the aircraft. So when you carry weight, you make money. So that's why. But as you say, it's a commercial factor. It governs the commercial factor of the aircraft. Titanium is another aluminum, and they're using carbon fiber also. So it's a combination. I'm not so familiar with carbon fiber, but I can give you an example, because if any of you ever get a chance to fly in an aircraft or go to London or something, sit near the window. When you're on the ground, you will, like the Dreamliner on Kenya Airways, if the ground, you will see the wing. If you look outside the wing, you close your eyes and put it in line with the ground anywhere. And then when the aircraft is flying, you will see the aircraft is, that wing has gone 10 to 15 feet up. That's a lot of movement, 10, 15 as high as this, maybe a little higher. So that much flexibility takes place. And when they use carbon, material is lighter, is stronger. Okay, because it's man-made fiber. Yeah. So when you have lightweight, that's why larger aircrafts have carbon fiber. They can carry more passengers, and the engines also are becoming very powerful now. So it's a question of design, which is power to weight ratio. You have to work it out. Yeah. So what is what? So if your airframe is a certain weight, you need certain amount of power to keep it in the, yeah, and sustain your flights. Basically, also, if you have the twin engine aircraft, if one fails, you can still fly the aircraft with one engine. Yeah. So those are all safety factors. That's design. You shouldn't worry too much about, unless you want to become academically aeronautical engineering degree course. Then you'll be sitting on the bench and just designing aircrafts and doing all these tests. Yeah. So everything on the aircraft is tested to destruction, actually, to see what the limits are. Yeah. It's not like they just thought of it